we are going over bonding in atoms. So the first bond we're going to go over is the covalent bond. Co meaning together, valent meaning the valence outer shell of atoms, which we're going to talk about. This is the strongest of the bonds. It is where sharing of two electrons takes place between atoms. Now, atoms, they tend to want to fill their outer valence shells. So there are different orbitals in atoms, and the outermost orbital or shell is called the valence shell, and this is where the electrons reside. Let's just take an example here of the simplest atom, which is the hydrogen atom, number 1 on the periodic table. It is number 1 on the periodic table because it has 1 proton in its nucleus. So remember that it is the number of protons that determines your atomic number and where you are on the periodic table. In the orbitals, what we see is 1 orbital, because it is a small atom, with only 1 electron, which is this one right here. This empty space here shows the space that a second electron could take within that first orbital. So again, we have 1 proton in the nucleus, 1 electron in the first orbital. In this case, the first orbital is the valence shell because it is the outermost shell. It can hold up to 2 electrons. Hydrogen only has 1 electron. This means that the shell is not completely filled, and for this reason, hydrogen will seek another atom to share electrons with in order to fill that outer valence shell. When it does so, we call that covalent bonding. Let's take a look at this example. We have a hydrogen atom over here, 1 proton in the nucleus, 1 electron in that first orbital, this empty slot here for a second possible electron. This hydrogen atom will look for another atom to bond with in order to fill this empty spot here where that second electron could go. So now imagine a second hydrogen atom on this side. It too has 1 proton in the nucleus, 1 electron in that orbital, and 1 empty slot there where a second electron could go to fill its valence shell. What's going to happen is that these 2 atoms will be attracted to each other and will want to bond by sharing these electrons. So what we see here is that they stick together, and now they are sharing electrons. We consider now that these 2 electrons are orbiting around one of the hydrogens, but also around the other hydrogen. So that now what you get is this electron cloud of 2 electrons orbiting around both these hydrogen atoms. We can shorthand write this as the letter H, that stands for hydrogen, a dash, which means 2 electrons bonded in a covalent bond, and another letter H for that second hydrogen. The other way we can write it is the letter H with a little 2 subscript showing that there are 2 hydrogens. And now we have a molecule. Instead of having individual atoms, we now have a molecule. A concept we want to introduce here is known as electronegativity. This is the amount an atom in a covalent bond attracts the electrons it is sharing. Now, carbon and hydrogen are equally electronegative. So that means that when they are sharing electrons in a covalent bond, neither carbon nor hydrogen will pull the electrons closer to it. The electrons will stay about in the middle of distance between the two atoms. Because of this, hydrocarbons end up being nonpolar. They don't have a polarity that forms of an imbalance of electrons giving an off-balance charge to one atom versus another atom in a covalent bond. We're going to see more of what this looks like further down. Let's see what the carbon atom looks like. So a carbon atom has 6 protons and 6 electrons typically. Here are the 6 protons in the nucleus. Here is the first orbital, but the first orbital can hold up to 2 electrons, which are right here, which means we have to create a second orbital in order to add more electrons, because we need to get to 6. Now, the second orbital, in this case, is the valence shell. The first shell is filled with 2 electrons. The second shell is the valence shell. The second orbital can hold up to 8 electrons. So here you have the 8 slots for the electrons in the second orbital. But to get to 6, the number 6 of total electrons, carbon will only have 4 electrons in that second shell. So it has 4 out of the possible 8 electrons in that second orbital or valence shell. This means that it will look to covalently bond in those 4 locations. Let's see what this looks like. Here we have a carbon atom with 6 protons. We have the first orbital with 2 electrons in it, and the second orbital, which, if carbon were by itself, it would have 4 electrons. But now notice that it has covalently bonded 4 times to 4 hydrogens. So notice there's 1 proton in each of these nuclei, which means we're talking about hydrogen, and each hydrogen has 1 orbital. The first orbital is the valence shell for these hydrogens. Those hydrogens would have 1 electron in each one of those orbitals. They would look to fill out that outer shell, and so they would find that spot on that carbon where that carbon is missing an electron, and it would form a pair, a covalent bond. So here you have a covalent bond on one side and the other side, and this side up here and another side down here, for a total of 4 bonds. This is methane. It's what it looks like when we draw it out. And we can shorthand write it with the carbon in the middle, these dashes showing the 2 electrons in a covalent bond, and there's 4 of them. And of course, we're bonding the carbon to hydrogen, which we draw out with the letter H. And you can see that that's how it looks like. Or you can write it like this with the letter C. Now, you don't put the number 1 in subscript because it's assumed. The letter H and the little number 4 in subscript to show that there are 4 hydrogens in that molecule. So again, this is a molecule because it is more than 1 atom, and these are covalent bonds creating this molecule.